Hello everyone, welcome back to my YouTube channel. So let us continue with the queuing systems, and in this last part of this subtopic will be the finite queue capacity. Okay, so a practical system cannot contain an infinite queue. See, practically we cannot have infinite amount of queue, and the infinite amount of queue is required to accommodate infinite amount of number of calls that are arriving. So it is practically not possible to have an infinite size of queue. Thus, when a queue has become full, calls that arrive are absolutely lost. Okay, let us say, for example, we have a queue of some 1,000 calls. Let us say, and if more than 1,000 calls, let us say 1,200 calls comes in, then 200 calls are lost. Okay, that is a condition. If the queue can only hold up to q calls, then x should be less than or equal to q plus n. That is, n is the number of servers that we have. Then the equation that is 4.12, that is the equation that is second Erlang equation that we discussed in the previous class. So that equation we'll consider over here, that is 1 by p naught is equal to summation ranging from 0 to n minus 1 a to the power of x divided by x factorial plus n divided by n factorial a by n to the power of n summation ranging from 0 to q a by n to the power of k. Okay, now so let us solve it further. This part will remain same, and if this will be converting it to a to the power of n divided by n to the power of n, then n to the power of n and this n will cancel with each other, a part of that, and will be remaining with e to the power of n divided by n factorial. And if you apply summation from k equal to 0 to q to this term, that is a by n to the power of k, then we'll be having simplified version as 1 minus of a by n to the power of q plus 1 divided by 1 minus a by n. Okay, let us call this as equation 4.16. However, if the loss probability is small, if loss probability is very small, then there is negligible error in using equation 4.13. So there will be negligible error in using the equation 4.13, that is what we have discussed in the this part, that is second Erlang distribution formula. Fine. Now, because of that, what we do is that the loss probability can be estimated by first assuming that q is infinite and then calculating the probability. So what we do is we assume that q is having infinite amount of capacity, and then we calculate the probability, that is the probability of x greater than or equal to q plus 1. Then we have, using equation 4.14, we have, that is probability of x greater than or equal to q plus n is equal to n to the power of n divided by n factorial a by n to the power of q plus n multiplied by n divided by n minus a p of 0. That is 4.14 we have over here, that is probability of x. While discussing delay, we have discussed that is p of x greater than or equal to z. We have n to the power of n divided by n factorial. This formula we are using over here, this relation. Okay, and if you replace this n to the power of n divided by n factorial and n by n minus a into p naught by p of d, then we have simplified version of probability of x greater than or equal to q plus n is equal to a to the power a by n to the power of q multiplied by pd. Hence, the q capacity q needed to obtain adequately low loss probability can be found by using this equation, that is 4.17. This completes the finite queue capacity. Thank you.